A very good morning to Madam. Now our group 9 will present the numerical assignment 2. Now I will present the introductions, and based on this assignment 2, the assignment is required the two students have to conduct an experiment to record the RPM. So the process flow of the experiment is started with resting 2 minutes, then continuing with the exercising, which is scribing will stay 5 minutes. After that, they rest for the 5 minutes and the RPM reading are taken every 30 seconds during the whole experiment. And based on the requirement of the text, after recording all the data, we need to use the numerical for analysis. The numerical method needed to use content, the interpolation, numerical differentiation, and the numerical integration. Now I will talk about the procedure for the whole experiment. Firstly, we find a place for stay and sitting down for 2 minutes. At this moment, the RPM reading are taking every 30 seconds, and after they rest for 2 minutes, they are starting to exercising for 5 minutes. Then finally recovery for the 5 minutes.
My name is Kogami. For the data collection part, we choose two students from our group and subject A and subject B. During the exercise protocol, the two students will do the same. We separate the exercise into 3 stages, which is rest phase, step climbing phase, and recovering phase. During the rest phase, stand quietly for 2 minutes, recovering heart rate for every 30 seconds. Second is step climbing phase, climbing up and down a staircase at a steady pace for 5 minutes, and then we record the heart rate every 30 seconds. Last, recovering stage, stop climbing and sit quietly for at least 5 minutes. Record heart rate every 30 seconds. Here is the data collection we do. And me, Kogami, and Liang Wen as a subject A and B.
Now for the interpolation for missing data, we are using the language interpolation polynomial to interpolate the heart rate data at 105 seconds. Since we are using the third order language interpolation polynomial, so the 4 nearest points are using is 60 seconds, 90 seconds, 120 seconds, 150 seconds, and finally we can calculate out the value of the heart rate for one-year student is 80.8125, and for the student Y2 there is 64.8125.
For part 3.2, numerical differentiation for rate of change of heart rate, we use 2-point forward difference to calculate the length of change of heart rate for two subjects at different points in the time. The numerical method used in this section is a 2-point forward difference method, which is given by the formula differentiation of fx equals to fx plus h minus f plus x, and then over h, and then we simplify the equation into heart rate equation, which is difference of h of time t will equal to ht plus 1 minus ht over t. The over t is every 30 seconds, and then we're doing the equations by when differentiation of heart rate at 0 seconds will equal to 75 minus 72 over 30 seconds. So we will get the answer 0.1000. And then at 30 seconds, which will equal to 83 minus 75 over 30, we'll get 0.2667. Either we using the formula calculate one by one for subject A and B, or I using the Excel is more easy and simple. We apply the formula and then we can get all the answer. So we will get the table on the right side. For the second question, plot the rate of change versus time for subject A and B on the same graph with clear labels. After calculating the rate of change, we plot the rate of change of heart rate versus time for both subject A and subject B on the same graph. The horizontal axis represents time in seconds, while the vertical axis represents the rate of change of heart rate in the BPM per second. Positive value indicates that the heart rate is increasing, which mainly occurs during the transition from rest to exercise. Negative value indicates that the heart rate is decreasing, which mainly occurs during the recovery phase after exercise was stopped. So this is the graph that we plot, followed by the table given. So we can see which is got a maximum value and minimum value. The right is for the red is for subject A and the blue is for subject B. The next question is identify the maximum positive rate of change during the start of exercise and the most negative rate of change during the recover. During the exercise, student A have a maximum rate of ppm per second is 0.166 as 150 seconds, and student B also have 150 seconds, which has a maximum rate of 0.233 bpm per second. Now for the most negative rate, student subject A at 600 seconds, which is negative 0.233, and then subject B at 480 seconds, which is negative 0.3333. Next question, compare who has a faster heart rate response when starting exercise and who recover faster after stopping. By comparing both subjects from a table, we can clearly observe difference in their heart rate dynamics. Student B demonstrate a fast heart rate increase at the start of exercise and a fast heart rate decrease during the recover. Student A show a very gradual increase and a slowly recovery. Those differences may influenced by factors such as physical fitness, cardiovascular efficiency, or individual physiological difference. Although those factors were not explicitly measured in this study.
So without any hesitation, let us continue with the 3.3 numerical integration for heat rate as a simple workload index. We using the heart rate for each subject, and we use the trapezoidal rules to approximate. This is show the formula. So it's the integration of start and end with the equation of Hg, and we convert to the trapezoidal rules formula is the h over 2, and then multiple with the start and the end, a total of the start and the end, and the plus 2 which is multiple with the center of the value, the total of the center of the value. Okay, so for the hash is we need to calculate which is the Sn minus with the S naught and divided with the n. So for the first, we total need to calculate three parts, which is the work session and the exercise phase only, and the recovery phase only. So this is show the result for the work sessions. For student A is greater than the student B. The value of student A greater than the student B, and for the exercise phase only, for student B is greater than the student A. This result is also same with sorry. The recovery phase for the student A is greater than the student B. So this in this project, we successfully demonstrate the practical application of numerical methods to model and analysis heat rate response during the physical exercise. So we use the Lagrange interpolations, numerical differentiation, and the trapezoidal rules for integrations. For the key we finding is the student B as experience a higher cardiovascular workload during the exercise phase. describes these greater accessions, student B also demonstrate a faster recoverment compared to the student A. And then what is the purpose we use the three of the method is because the Lagrange interpolation ensure the data completeness for the continuous analysis. For the numerical differentiation is we can realize the student B had a steeper hit rate rise at the exercise outset and a steeper fall during the recoverment. And then for the trapezoidal integration, we quantified that student B had a RAS exercise workload but a smaller recoverment workload. So the last two which is the integration result represent the cumulative effect of the heat rate change captured by the differentiations. That's all for our result. Thank you.